In this project, we will build a handy infrared repeater circuit. Essentially, you will be able to record up to 3 infrared signals. Here is how the circuit will work. Simply point a remote at the circuit and press the appropriate button on the remote for the signal you want to record. Then press a button on the circuit to associate with and store that signal. Later on, to play back that signal, point the LED on your circuit to the device you want to control and press the button. The cool thing about this project is that even when the circuit is powered off, when it is powered back on, the signals you stored are persisted so it remembers them. You can house your circuit in a box, and you have a universal remote that can copy and play back any IR signal. How cool is that? Let's take a look at the objectives. By successfully completing this project, we will have mastered the following items. You will understand how infrared receivers and LEDs work. You will learn how to connect an IR receiver and LED in your circuit. You will also be introduced to the popular IR remote library for working with IR components. You will see how easy it is to record and play back signals. And you will be introduced to the EEPROM and its get and put methods for storing data that can be retained even when the Arduino is powered off. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, an infrared receiver. We'll be using the TSOP382 model. It's a very popular, inexpensive IR receiver, an IR LED, a 220 ohm resistor, 3 push-button switches, and connecting wires. Before we get into our projects, let's first talk about infrared technology, or IR. IR is a common, inexpensive, and easy-to-use wireless communication technology. IR light is similar to visible light, except that it has a slightly longer wavelength. IR is undetectable to the human eye and is perfect for wireless communications. Here's how it works. IR signals are all around us, but for a device such as your TV to pick out signals from your remote among all other ambient IR signals, the IR signals transmitted are modulated. Modulating a signal is like assigning a pattern to your data, so that the receiver knows how to listen for them. A common modulation scheme is called 38 kHz modulation. There are very few natural sources that have the regularity of a 38 kHz signal, so an IR transmitter sending data with that frequency will stand out among the ambient IR. When you hit a key on your remote, for example the volume up button, the transmitting IR LED will blink quickly for a fraction of a second and transmit the modulated, encoded data to your appliance. The receiving device will then demodulate the signal and output a binary waveform that can be read by the microcontroller. In our project, we will take the input from a remote, store the sequence that is sent to our circuit, and play it back on demand. Pretty cool, huh? The IR receiver has 3 pins. The VCC pin is connected to 5 volts. One pin is grounded, and the other is the signal pin, which is connected to your Arduino. Let's take a look at the circuit diagram for our project. In the first circuit diagram, we'll simply be demonstrating how an infrared signal can be received and transmitted again. For our IR receiver, there are 3 pins. One of the pins are connected to 5 volts, and another pin is connected to ground. The signal pin will be connected to pin 11 on the Arduino. For our IR LED, the cathode or shorter pin is grounded, and the anode or longer pin will be connected via a 220 ohm resistor to pin 3 on the Arduino. Next, we have a push-button switch, one end of the switch is grounded, and the other end of the switch goes to pin 12 on your Arduino. Also, you have to remember to connect the ground pins and the 5-volt pins to the ground and 5-volt rails on the breadboard. That's the wiring for our circuit. Okay, let's go ahead and wire up our first circuit. So first we have the IR receiver. This is what it looks like. It has 3 pins. So I'll go ahead and put that in. I'm going to use a smaller breadboard just to make the circuit a little more mobile when we test it out. So this is a smaller version of a breadboard. Things might be a little tight, but we'll try to get everything in there. So there is our receiver. Then I'm going to put in our infrared LED. So as you'll notice, it looks a little different from our normal LEDs. It's clearer, but this is an infrared LED. Okay. Next, I will put in the push button switch. So I will put this in on the extreme left of the circuit. All right, so this goes in snugly there. Let's first connect the infrared receiver. So from one pin, the leftmost pin, we're going to go to pin 11 on the Arduino. That's the signal pin. All right, so I'm going to connect that to pin 11. The middle pin is going to be grounded, so I'll make that connection now. And since on our IR LED we also have to ground the cathode, I'll just connect this here, connect those 2 pins together, and then I'm going to jump from that pin to the ground on the Arduino. So I'll go from ground on the Arduino, and I'm going to go to ground here. All right, so essentially we have grounded both the IR receiver and the IR LED by that connection. Next, we'll connect the 5-volt pin on the IR receiver. So that goes to 5 volts. Go across here, and I'll make that connection to 5 volts. Okay, so that is that connection. For our IR LED, we have that resistor. So I'm going to put that 220 ohm resistor, and that has to go to pin 3 on your Arduino. So I'll go ahead and make that connection here. And the other end of that resistor will go to our pin 3 on the Arduino. Okay, so as you notice with this smaller breadboard, the same concepts apply like the big breadboard in that these rows here are horizontally connected. Okay, and there is a break in the middle of the breadboard again, so just bear that in mind. The similar concepts apply. Now let's finish up with our switch. So one end of the switch goes to ground. So I'll make that connection here. And we can use that same ground connection. All right, that's with our LED. So I just connected it along that same row. All right, it's kind of difficult to see here, but all of these are on the same row, they're all grounded. And then the other end of our switch goes to pin 12 on your Arduino. So I'll make that connection. And we're going to go to pin 12. All right, so that completes the wiring for our first circuit. Before we go ahead and upload the code to run our project for the IR record and send circuit, one thing you'll need to know is that you have to install the Arduino IR remote library. This is a link to it. I will post it in the resources for the project. So when you come out here, of course, you would download the library, extract the zip file, and you would put it in the libraries subfolder of your sketchbook location, just as we have seen before in how you install third-party libraries. One issue you may run into, and there's an ongoing bug in the Arduino forums is that you may get a conflict with an existing bundled Arduino library, which is the robot IR remote library. So to handle this, if you look at where your Arduino is installed, Java subfolder, you can go ahead and click on that. You'll see libraries. In there, you may see that robot IR remote library, and this is where all of the libraries that come bundled with your Arduino installation, this is where they are housed, as opposed to your sketchbook location where you can put in custom third-party libraries. When Arduino is installed, anything that comes bundled with it is located in this Java libraries subfolder. Go ahead and delete that robot IR remote folder and everything that's everything that's within there, and restart your Arduino IDE, and that should take care of the conflict problem. For those that are on Windows, you can find that path very easily to wherever your Arduino is installed and go to the Java libraries folder. For those of you that are on the Mac, what you'll need to do is you'll need to click on your Arduino app and do show package contents, okay? And then when you look at the contents, that's how you could get to the Java and that library subfolder to delete the robot IR remote library. But just wanted to make you aware of that in case you run into any issues. And again, this depends on the version of the Arduino IDE you have installed. The later versions should have corrected this, but you may run into issues there. Okay, let's go ahead and upload the code for our IR receive sample project. So the name of that particular the particular program we're going to use is IR receive. So go ahead and upload that. And while that's uploading, I'll just open up the serial monitor here. So essentially what this program does is it shows how the IR receiver actually receives a signal that is sent via a remote. So here is a remote for a Sony TV that I have. So I'm going to go ahead and if you look at the serial monitor, when we send an IR signal to our receiver, it's going to receive it and display what that signal is. So I'll go ahead. I'm going to press the power button. And you'll notice A90 is that decoded signal. So our IR receiver was able to receive that signal and correctly process it. I'll just try some of the other buttons here. So I'll press, for instance, the 1 button. All right, so you see 10 showing up. I'm going to press the 2 button. I'm going to press the 2 button. There we go. The 3 button. All right. The 5 button, and so on. So you'll see, even when I go to volume up, all right, you see that it's being correctly received by our circuit. So that's that sample program. So in our next program, the IR record, we're actually going to send a signal to our circuit, and then when we press the button, that signal is going to be played back. So I'll go ahead and upload that code now. And I'll open up the serial monitor. All right, so our program was uploaded. And I am going to, let's press the power button for our circuit. So I'll go ahead and press the power button. So as you can see, it says receive the Sony, and it tells you what the code is. And now, if I were to press our button on our circuit, it actually sends that back out. So it's sending back out that code. Similarly, for the volume, so I'm going to press the up volume button here. So it received that 490 code. And if I press the button, all right, as you can see, it's going to play back that particular code. So that's pretty cool in that, we're able to send. Let's try out the number 8 here. I'm going to press the number 8 button. All right, so it received that code. And again, I can play that back. All right, so that's pretty handy and pretty nifty and pretty cool. It's using the IR receiver to receive the signal, and then it's using the IR LED to play back out the signal. In the next project, we're going to make a modification to store 3 signals but actually persist it, so that when the circuit, right now if we remove power from the circuit, it's going to forget what that signal is, but we're going to make modifications to store 3 signals and persist those. So that will be in the next project. Okay, let's take a look at the code for our IR receive circuit. This was a example program written by Ken Sheriff, who wrote that great infrared library. So this is what we used to be able to receive a signal on our IR receiver. So initially we include the IR remote library, and our receiver pin was pin 11. We create the IR receive object, and we pass in that pin as the argument to our constructor. Next, we have a results global variable, which is of the type the code results. And again, these two are coming from our IR remote library. In our setup function, we begin the serial communications, and we do an enable IR in to start the receiver, and we call that method on the IR receive object. In our loop function, which is very short, basically we do an IR receive.decode, and we pass in a reference to that results object. And basically what we're doing here is, once we have received a signal, we simply get that in, we decode it, and we display the results out. After we receive the signal, we do a IR receive resume, and we just wait to receive the next value, and then we continue looping on. So that's our program, very short, but it demonstrates how we are able to receive any infrared signal sent to our circuit and decode the signal that was received. Okay, let's take a look at the code for our circuit that was able to receive and play back one infrared signal with a button. So at the beginning, we include our IR remote library, and we set up a couple of global variables. So we have the receiver pin as pin 11, our button was connected to pin 12 on the Arduino, and we have the status pin, which is the pin 13, that's the built-in LED on the board. Next, we construct our IR receiver object, passing in the receiver pin, and then we also create an IR send object. So those are those two variables there. We also have a decode results global variable called results, and we will use that to store our results. Next, in our setup function, we begin serial communications, and we start up our receiver by calling the enable IR in method on the IR receive object. Next, we enable the input pull-up resistor on our button pin. So we do a pin mode button pin input pull-up, and we set the status pin as an output. Moving on, there are some other global variables that are initialized. A lot of this was taken from the IR send sample program that comes bundled with the IR remote library. So here we have some variables where we use to store the code value and the raw codes. So we set some of those values up, and there's a global toggle variable that we use to maintain our RC5 or 6 toggle state. So here is the store code function. It basically takes in that the code results variable or reference to that variable. And in here, in this function, we are essentially storing the code. So when the code comes in, we're first determining what it is, and a lot of this code is from from the sample program with my Ken Sheriff. So we're able to determine what code was sent in based on the device, and we store the code in our results object. Then, when we want to send the code back out, we have a send code object, and we pass in a repeat parameter if the code needs to be repeated, and as the function says, it just sends the code back out. So a lot of logic in there around receiving a signal and sending it back out. In our loop function, a few things we're doing here. Basically, we're determining if the button was pressed, and if that was the case, we send the last code that was sent in. So we call the send code function. And if a new signal had come in, this is where we store that code for later playback when we press our button. So that's it. That's our IR record program.